So our final example for lesson 1.3 is where we're going to sketch piecewise defined functions. So a lot of piecewise defined functions are just, it's either two or more functions that we're only given parts of each function. So together they make one giant piece, but it's called a piecewise because there are two or more equations that set up this one function. If you look at what we are given, we kind of talked about piecewise functions before, but here you have two functions. You have a negative 1/2 x minus 6, but it's only defined when x is less than or equal to negative 4. And then you also have x plus 5, which is only defined where x is greater than negative 4. So what we have is we have two lines here, if you look at the equations, but they're defined on two totally separate parts of the graph. So the top line is only going to be drawn from where x is less than or equal to negative 4. The bottom line is going to be where x is greater than negative 4. So you can do these a couple different ways. A newer, different way that I've chosen to graph these is by making tables. So if we make a table for our first equation, we have a negative 1/2 x minus 6. Well, the table, you only have to, since we're graphing a line, you only need 2 points. Well, you are given 1 point right here. So we're going to plug negative 4 in for our first point. Now your second point, your second x value you can plug in, that's anything that is going to be less than or equal to negative 4. So if we're at negative 4, we need to choose another number that's to the left. So you can either choose negative 5, negative 6, negative 7, anything. You can choose decimals, heck, I don't care what you use. But since we're going to find a half of a number, I'm going to plug in a negative 6. You could do negative 5 if you like, but I'm just going to do negative 6. So if you plug this in, you get a, let's see, if you plug in negative 4 in here, negative half of a negative 4 is a 2, positive 2. 2 minus 6 gives you a negative 4. So there's our first point, and I'm going to graph that before I find my next one. So if I go to back 4, down 4, I'm going to have a point. Now, will this be colored in or will this be an open circle? According to your sign right here, that is going to be a colored in dot. So we'll make that a little bit bigger. Now we need to find a second point. Now this says x is going to be less than or equal to negative 4. So the rest of this graph should be going to the left of this point right here. It shouldn't be anything graphed to the right here in blue. So if we plug a negative 6 in, half of negative 6, a negative half of negative 6 is 3. 3 minus 6 is a negative 3. So we're going to go back 6 and down 3. So that's going to put us negative 1, negative 2, negative 3. Here's our next point. So you can tell this, if you start at your first point in your graph and you go to the left, here is your first piece of your function going to the left. Now the other function we have is x plus 5. And in order to graph this, you need 2 points. And your first point is given to you at negative 4. Now, we know the rest of our graph is going to be over here to the right somewhere. Drawn some lines. I don't know how it's going to go. But we also know we can't have another closed circle. We're going to have an open circle here somewhere. The other reason we know that is because you have a greater than, not equal to, just a greater than. So we're going to choose a negative 4, and then we're also going to choose another number that's bigger than that. So let's just choose 0. 0 is always a nice number to plug in. So if we have a negative 4, we're going to plug in negative 4 in our equation. Negative 4 plus 5 is a 1. So we're going to go back 4, up 1, and we're going to have an open circle. And remember, the reason we have an open circle is because this is just greater than. So now if we plug a 0 in, the reason I plug 0 in, 0 is so nice to plug in, 0 plus 5 is just 5. So your second point for your line is 0, 5. Draw your line in here. This shows your piecewise function. Now we don't have to find the domain and range here, but if you did, your domain, okay, how far is this graph go to the left? How far does it go to the right? Well, your domain would be all real numbers. So it goes all the way to infinity. Comes up to -4, stops for your blue graph, but it hops up on your red one and goes to the right. So from negative infinity to positive infinity. And your range, that's your y values. Well, what's the lowest this graph go? But the lowest it goes is -4. The highest this goes, well, this graph keeps going up and up and up and up. Once it hits y equals 1, it's still going up, but it also jumps over here to the red one. So you have two parts of your graph that would be going up all the way to positive infinity. Now the only other thing we need to talk about with graphs would be whether it is an even or odd function. Even functions, and that is where you can plug in a negative x into your function, and if it comes out and gives you a positive, or the original function, then it's going to be an even function. So even functions are symmetric about your y-axis. If you just chop it up, you're going to get the same thing, or chop it in half, you're going to get the same thing on both sides. This graph, if you fold it on your y-axis, you cannot get the same thing on both sides. Same thing here. Odd functions, student functions. This is if you plug a negative x into your function and it ends up, you would have a -1 times your original function. That would be an odd function. That is where it's symmetric about your origin. Basically what that means is you could flip, I would say you would flip over your x-axis and your y-axis. So if you took this piece of paper, flipped it over this direction, you'd have a graph going like so. And then if you flipped it up one more time, then these pieces would be on top of each other. So you can have two flips. This last graph is neither symmetric about your x or your y, or your origin or your y. So it's basically just a horrible graph. Sorry graph, but anyway, well, this concludes our chapter notes for 1.3. So I hope you have enjoyed, and good luck on your homework.